Hello everyone, I'm Danula Hettiachchi. I'm a research fellow at the RMIT University, Australia. Crowdsourcing is widely used to collect annotations and complete tasks that require human expertise. And in this work, we identify a particular class of crowdsourcing tasks called tasks that require variable effort. Now, these tasks involve two steps, where in the first steps, workers go in and try to identify the number of target objects through a search task, and then they do the actual annotation task. And in these tasks, annotation effort really depends on the number of search results that you get. Naturally, some items that you annotate during this process will require more effort than the others. So when we consider variable effort tasks and compare them with regular crowdsourcing tasks, there are some challenges that we identify. First, in variable effort tasks, workers get an inconsistent experience because of this variable workload. And then there is a potential for high cognitive load, particularly because these tasks involve two steps and a searching task as well. And then because we don't know the amount of effort required a priori, and because it can vary a lot, designing effective incentives for these types of tasks can also be very challenging. In this work, we set out to understand how output quality changes when we are handling crowdsourcing tasks that involve variable effort. And in particular, we want to design a quality control mechanism that can produce high quality annotations for variable effort tasks. And we are also concerned about fair compensation, because the compensation should reflect the amount of effort that they exert on these images. So going through a bit of background on this problem and domain, financial incentives and crowd work has been extensively studied. People have proposed different approaches that can ensure fair compensation for workers. When it comes to effective mechanisms that can improve the data quality in crowdsourcing, research has investigated different workflows. For example, there are iterative and parallel workflows that has been shown effective in particular tasks. In practice, task requesters often use gold standard questions. Now, these gold standard questions act as quality checks, where we provide a task with a known answer or a ground truth to workers to assess how they work on this particular task. We can also use gold standard questions as a training question, where you would provide feedback to users. Now, this is, we frame this as visible gold. And of course, in crowdsourcing literature, we see that feedback is often helpful for workers. And then there is previous work that use gold standard questions as training questions. And particularly in this work, we are looking at the bounding box task. And of course, there is work that looks at different ways that can improve the annotation quality in bounding box tasks. These include semi-automated approaches as well. However, when it comes to this particular problem of variable effort, we see that most of the previous work involve data sets that has, on average, low number of objects per image. And in our work, we use a curated data set that is derived from the open images for the bounding box task. In our data set, we have 140 images with known ground truth. Talking about our experiment strategy, we deployed all our experiment conditions in Amazon Mechanical Turk, and workers who were qualified for the AWS ground truth bounding box task were able to attempt these hits. And this worker cohort includes more than 8,000 workers. So in our experiments, workers could only attempt a single condition. And we also maintained a constant payment that is in line with the amount of bounding boxes they annotate, and which is also higher than the standard minimum wage in the United States. In terms of measures, we used recall, mean, intersection over union, and task time to evaluate our results. So we first looked at the baseline setup, where we just use a standard annotation interface in Amazon Mechanical Turk, and then use the pay-per-task pricing model, where we pay a fixed amount regardless of the number of objects that you have to annotate in the image. So when we use this model here, you can see the annotation quality drastically drops when the number of objects or number of gold boxes in the image increases. Then we looked at different task designs informed by the literature that can help us achieve high data quality in variable effort scenario. So obviously the first one that I explained earlier is the baseline setup. And then we looked at variable pay. In variable pay, we try to compensate based on the number of objects that you have to annotate in the image. So of course, in the experiment setup, because we have the ground truth, we set this payment beforehand. And the third design is post-task bonus. So in post-task bonus, we set the initial payment to a fixed rate for all the images, but then after the annotation is completed, we provide a bonus payment corresponding to the number of objects that they annotate in each image. Fourth, we use task decomposition. So in our case, we use two conditions where we ask workers to decompose the task in a separate step and then ask them to annotate in the second step, which we call task decomposition manual. And also to ensure that we have consistent decomposition in the first step, we use a separate condition where we do the decomposition using ground truth data and then ask workers to annotate. Then we have iterative improvement. Of course, in the literature, we see that some of the iterative workflows can be helpful in particular tasks. So we ask workers to annotate a fixed number of bounding boxes in each step, whereas another worker would come in and annotate the same image, adding additional boxes. And then we have visible goals. So the goal of visible goal is to provide immediate feedback to workers, which uses ground truth data. When it comes to the results of this first round of experiments, here you can see across all the methods, annotation output quality drops along with the number of gold boxes or the number of ground truth boxes that we have in the image. Moving on to the visible gold part of the study, from promising results from experiment 1, we further developed visible gold mechanism as a general quality improvement mechanism that can be used for different tasks. Particularly when it comes to visible gold, it helps workers because it provides transparency around the expected task outcome, which also lead to task clarity because we provide examples. And then it also provides feedback, immediate feedback to workers that would help them to improve their performance while engaging in the task. Here you can see an example interface from our experiment where we provided immediate feedback to workers. Workers get localized feedback. For example, they get feedback for each of their annotations in the image. Then we provide a summary where we indicate how many bounding boxes they missed overall and what's their current accuracy is. One of the things that we have to investigate when we use visible gold is what the issuing pattern is. So for example, you could use an upfront pattern where you ask workers to only complete 5 visible goals at the beginning, or you could use them within the task. So we experimented with several visible gold issuing patterns. For example, we used a regular pattern where you occasionally encounter a visible gold during your experiment at a regular rate, or where you encounter visible goals with a fixed schedule that is informed by the Fibonacci sequence. So the motivation here is that we test workers more frequently at the beginning, and then we test them less frequently after a certain amount of time as they keep on working. When we look at results from the second round of experiments, you can see that visible gold methods always significantly outperform the baselines. And in particular, our improved visible gold method provides 7.5% improvement. When we compare our visible gold method with other available methods that we also explained in the first experiment, you can see our improved visible gold method holds well when we improve the number of target objects in the image. And both in terms of recall and mean IOU, you can see that it outperforms almost all the other methods. So overall, we anticipate that our work will be helpful for both crowdsourcing platforms and workers to produce high quality annotations. Thank you.